السلام عليكم ورحمة الله وبركاته. in this chapter we are going to learn more about rate of return analysis. راح نتعلم عن rate of return, or sometimes we call it internal rate of return, and how to do decisions based on the internal rate of return. At the beginning, just let's examine some examples about rate of return. In 1958, American citizen bought a Ferrari. اشترى سيارة فيراري 335S, and he drove this Ferrari for approximately 1 year, and it broke and needed some maintenance. He sent it back to the dealer, and the dealer decided that the maintenance cannot be done in the US. It should be shipped back to Italy to Ferrari factory to be maintained for maintenance. In Ferrari factory, they did the maintenance for the car, and it cost $12,000 at that time. And the price of a new Ferrari, this model, was approximately $7,000. So the person decided not to go and collect the car, and he left the car in the customs warehouses. ترك السيارة في مخازن الجمارك لحد ما اجى شخص ثاني في سنة 1963. Another person in 1963, he bailed this car out for $1,000. طلع او اشترى هاي السيارة من الجمارك مبلغ مقداره $1,000. Later, he sold this car for $21.5 million in private transaction to Austrian collector. باع السيارة هاي لشخص نمساوي بمبلغ مقداره $21.5 مليون. If we calculate the rate on investment for this investment, it is 2,155%. 2155% العائد على الاستثمار. يعني $1,000 تضاعفوا 2155 مرة لحتى وصلوا لل $21.5 مليون. Another example is Walmart Corporation. Walmart went public in 1971. The price of Walmart share at that time was $16.5. سعر السهم من والمارت كان $16.5. إذا الواحد اشترى 100 سهم, if you buy 100 shares, they will cost $1,650. راح يكلفوا 1650. And in 2014, approximately after 43 years, they will worth approximately $15,767,500. بعد 43 سنة بال 2014 راح تكون قيمتهم 15 مليون. Rate of return for this investment بيساوي 23.76%. 23%. إذا الواحد ما بده ينتظر لفترة طويلة, if you don't want to wait for a long time to have a good rate of return, go for Apple shares. In 2009, Apple share was $12.42. سعر السهم من شركة أبل كان تقريبا 12.42% من الدولار. And in 2015, just after 6 years, the share price is $131.95. 131.95% من الدولار. يعني تقريبا return on investment 48%. 48% العائد على الاستثمار. So, what does it mean rate of return or internal rate of return? Generally we can define the rate of return as interest earned on invested capital. الفائدة الواحد بحصل عليها على رأس المال المستثمر. Sometimes we call it internal rate of return. We have different definitions for it, like rate of return, or different names: rate of return, ROR, internal rate of return, IRR. All of them have the same meaning. In Investopedia, according to Investopedia, IRRs can also be compared against the prevailing interest rate, تمام, in the securities market. يمكن نقارنها بسعر الفائدة ايش؟ سعر الفائدة اللي موجود في الأسواق المالية. If a firm cannot find any project with IRR greater than the returns that can be generated in the financial markets, they simply choose to invest their money in the financial market. الشركات إذا ما قدرت تلاقي مشاريع أو مشروع يقدر يعطيها internal rate of return أكثر من سعر الفائدة السائد في السوق المالية, بكل بساطة بإمكانهم يحطوا فلوسهم وين؟ في السوق المالية أحسن من إنهم يستثمروها في المشاريع. Uh, we go back to Walmart investment and to see what does it mean 23.76%. If you have $1,650 and you bought a Walmart stock and you will get $15 million after 43 years, this means 23.76 rate of return in 43 years. Comparingly, you can invest your money in a bank. بدل ال 1650 بدل ما اشتري فيهم اسهم من Walmart, I can put them in a bank and the bank will give generally 6% interest rate. After 43 years you will have $21,000. راح يكون معي 21,000 بعد 43 سنة. So obviously buying a Walmart stock is better than investing your money in a bank. Why we choose the 6%? 6% in 1970s were considered the minimum attractive rate of return, MARR, for any investment. So if the investment or the project generates internal rate of return greater than 6%, then it is viewed as acceptable or profitable. Now we come to the definitions of rate of return. We have different definitions for the rate of return, but all of them mean the same thing. The first definition is the interest earned on a loan balance, الفائدة المتحصلة على القرض. Usually banks use this definition. هذا التعريف بيستخدموه البنوك. أنا أخذت قرض من البنك, I took a loan from the bank, I have to repay the loan plus interest. The interest rate is إيش؟ The internal rate of return or the rate of return for a bank. The second definition is the break-even interest rate. What does this mean? اللي هي نقطة التعادل. Interest rate اللي بوصل لنقطة التعادل. Break-even means that it is the interest rate at which the present worth for cash inflow for a certain project equals the present worth for cash outflow, or simply the interest rate that makes the present worth of a project equals to 0. And we use this definition to calculate the internal rate of return for any project. The third definition is the return on invested capital, internal rate of return, and usually this definition is preferred by companies. الشركات بتفضل هذا التعريف. It is the interest rate that makes the project balance at the terminal year equal to 0. Or in equations, it is the interest rate that makes project balance at the nth year equal 0. And if you can remember from chapter 5 present worth analysis, that the project balance at the terminal year equals the future worth for that project. And if the future worth project balance equals 0, this means future worth equals 0, and also present worth is also equal 0. So definition 3 is somehow the same as definition 2. Now, how to find the rate of return? Before we go deep in calculating the internal rate of return, we have to look at two definitions for projects, or two classifications of projects. We can classify projects to simple investment and non-simple investment. What we mean by a simple investment is a project that starts negative and the cash flow changes its sign only one time. So this is negative, net cash flow is negative, it is negative here, and now it changes its sign to positive and remains positive. So there is only one sign change for this project. Similarly, this project, the cash flow for this project starts negative and becomes positive one time. So there is only one sign change in the net cash flow. يعني السمبل انفستمنت هو المشروع اللي بيبدا نيجاتيف وبغير الكاش فلو بيبدا نيجاتيف وبغير اشارته مره واحده خلال عمر المشروع. We call it a simple investment. Non-simple investment, on the other hand, starts negative and the cash flow changes its sign multiple times. الكاش فلو بيبدا نيجاتيف وبتتغير اشارته عده مرات خلال عمر المشروع. So this project starts negative, becomes positive. This is one sign change, back to negative, a second sign change, back to positive, and remains positive. So it changes its sign 3 times. So this is a non-simple investment. Similar to this project, negative, 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 the cash flow, and changes its sign to positive, positive, then changes the sign to negative, then positive. So in total, it changes its sign 3 times. Let's see this example. We have 3 projects, A, B, and C, and we want to classify them as simple and non-simple investments. So for project 1, the sign changes only one time. So this is a simple investment. For the second project, and for project B, the cash flow changes its sign 3 times. And for project C, it is different. So for project A, one sign changed. This means it is a simple investment. For project B, it changes, it starts negative, and note that project A starts negative, and also project B starts negative, but project C starts positive. In project B, it starts negative and changes the sign 3 times, so it is non-simple investment. For project C, it is different because it starts positive. We call it simple borrowing investment. It cannot be classified either as simple or non-simple. يعني ما بنقدر نصنفه as simple or non-simple. بنصنفه simple borrowing project. And if you can see the diagram for project A, there is only one interest rate that makes the present worth equal 0. This is the present worth, and this is the interest rate. At 44.23, the present worth is 0. And if you go back to the definitions, the interest rate that makes the present worth equal 0 is the internal rate of return. And for project B, we can see that there are 3 values of interest rate that makes the project present worth equal 0. 10%, 30, and 50%. So 10%, 30, and 50 are all of them internal rate of returns for project B. كلها بنصنف على انها internal, أو all of them are internal rates of return. So now we know how to classify projects to simple and non-simple projects. Now before calculating the number of I stars or internal rate of returns, and we saw that a certain project, some projects may have multiple rate of returns. So before proceeding to calculating the internal rate of returns, we need to know previously how many rate of returns to expect. يعني قبل نروح ونحسب الانترنال ريت اوف ريتيرنز، لانه بعض المشاريع ممكن يكون لها اكثر من انترنال ريت اوف ريتيرن، بدنا نشوف كيف ممكن نتنبأ في عدد الاي ستارز، الانترنال ريت اوف ريتيرنز for any project. We have 2 rules for this. عندنا قاعدتين. The first rule is net cash flow rule of signs. قاعدة تغير إشارة النت كاش فلو. The rule says that the number of real I stars, internal rate of returns, for a certain project within period is never greater than the number of sign changes in the sequence of the cash flow. بالعربي عدد الانترنال rate of returns الاي stars لا يمكن أن يكون أكبر من عدد مرات تغير الإشارة الكاش فلو. If a project, for a certain project, if the net cash flow changes its sign one time, then there is a maximum of 1 internal rate of return. عندي maximum كحد أقصى rate of return 1. If the project changes or the net cash flow changes its sign 2 times, الكاش فلو بغير إشارته مرتين, there is a maximum of 2 internal rate of returns. عندي بحد أقصى 2 rate of returns. I may have 1, I may have 0 rate of return, but the maximum is 2. If the project cash flow changes the sign 3 times, then a maximum of 3 internal rate of returns. This is the maximum. But I may have 2 rate of returns, I may have 1 rate of return, I may have no rate of return. But the maximum is 3. So, in the case of multiple rate of returns, if I apply this rule, net cash flow rule of science, and I found that the cash flow changes its sign multiple times, then I have to apply the second rule, accumulated cash flow sign test. I have to calculate the accumulated cash flow, and the rule states that القاعدة بتحكي لي if a cash flow starts negatively إذا بيبدأ سالب and changes its sign one time, then there is only one I star. There is only one rate of return. So the conditions are شروط starts negative, changes its sign one time, then I can say this project have only one rate of return. Now, example 7.2, we have 4 projects and we want to predict how many internal rate of returns to expect from these 4 projects. First of all, we apply the net cash flow rule of science, قاعدة تغير إشارة الكاش flow. For project A, there is only one sign change. For project B, this is the first sign change, second, third, and fourth. So the sign changes 4 times. For project C, 0 is not considered as a sign change. 0 have no sign. So if the cash flow is 0, we ignore it. We have 2 changes of sign. For project D, we have the first sign change, 0 is not considered. We exclude the 0, and we have another sign change. So for project D, we have 2 sign changes. Then, since project A changes its sign one time, I can say there is a maximum of 1 IRR or no rate of return. يعني يا اما يكون عندي rate of return واحد او ممكن يكون عندي maximum واحد وممكن ما يكون عندي ايش internal rate of return لهالمشروع. Project B changes its sign 4 times, then a maximum of 4 rate of returns exist, but I may have 3, I may have 2, I may have 1, or I may have no rate of return. For project C and D, the same 2 sign changes. This means maximum of 2 rate of returns, but I may have no rate of return or 1 rate of return. Now, for projects B, C, and D, since we have multiple rate of returns, then we have to apply the second rule, the accumulated cash flow sign test, to see that if we can reduce the number of internal rate of returns. The accumulated cash flow, we calculate the accumulated cash flow according to the following table, as you can see. So for project A, project B, it is minus 100 plus 50 minus 50 in the first year, plus minus 100 minus 150 in the second year, plus 60 minus 90 in the third year, plus minus 100 minus 190 at the fourth year. And the same for project C, 0 plus minus 50 minus 50, plus 115, 65, plus 60, plus minus 66 minus 1, plus 0, this is minus 1, typo error. Project D, minus 100 plus 50, minus 50, plus 0, minus 50, plus 200, 150, minus 50, 100. So we apply now the accumulated cash flow sign test. The rule states that it must start negative and changes its sign one time, then I can say there is only one rate of return. So for project B, starts negative. For project C, starts negative, we exclude the 0. For project D, it starts negative. Now, the second condition is that it changes its sign one time. For project B, it doesn't its sign and it remains negative. So it doesn't pass the condition. For project C, it changes its sign only 2 times. So it fails the test. For project D, we can see it changes its sign only 1 time. So project D have only one internal rate of return. If you remember that from applying net cash flow rule of science, it had 2 sign changes, so maximum 2 rate of returns, But after applying the accumulated cash flow sign test, I have reduced the number of rate of returns to one internal rate of return because it has passed the test. For project C, there's no, the rule doesn't apply for project C, so I cannot say that I have one rate of return. The possibility of two rate of returns still exists. Now for project B, there is a special case. Project B is a special case because it remains negative. Starts negative and remains negative. In this case, project B has no rate of return. There is no rate of return for project B. If you remember that after applying the net cash flow rule of signs, it had 4 sign changes, so maximum of 4 rate of returns. But after applying the accumulated cash flow sign test, it starts negative and remains negative. This means it has no rate of return. So instead of maximum 4, we have concluded that project B has no rate of return. Now, to calculating I star. How to calculate I star? There are different methods to calculate I stars. And remember that we can calculate the internal rate of return from this equation, the break even. It's the rate of return that makes the present worth equal 0. So we can solve it using this equation. And if you remember that present worth, if I'm going to apply the formula for present worth, it is A naught plus A1 over 1 plus I plus A2 over 1 plus I squared plus an over 1 plus I to the power n equal 0. This is a polynomial. Let us assume that x equals 1 over 1 plus I. We will have a naught plus a1x plus a2x squared plus an xn to the power n equals 0. This is a polynomial. And we know that for a polynomial, the roots of a polynomial is equal to the highest degree of the polynomial. جذور الكثيرات الحدود بتساوي ايش؟ الباور الاعلى للبولينوميال. يعني اذا كان عندي بولينوميال من الدرجه الثالثه I will have 3 roots. If I have polynomial third degree I will have 3 roots. Polynomial of degree 10 I will have 10 roots. Okay, so mathematically I have n interest rates. Mathematically, because I have n years, I will have n interest rates because I will have n roots. But as you have seen from the previous example or the previous rules, that we can reduce them based on the net cash flow rules of rule of signs or the accumulated cash flow sign test. You can see for these projects, number of years is 4. So mathematically, if I'm going to solve B present worth equal to 0, I will have 4 interest rates or 4 roots, 4 جذور. لكن لما جينا طبقنا قاعدة net cash flow sign rule والaccumulated cash flow sign test, for project A, I have concluded that we'll have only one rate of return. For project D, I will have one rate of return. For project C, I will have 2 rate of returns. For project B, 0 rate of returns. There is no rate of return. Okay? So by solving this equation, we will have the the value of the internal rate of return. And since I will have polynomial for a linear for n equal 1, I will have a linear equation. It is easy to solve linear equation. Quadratic equation is also easy. Third order polynomial, relatively easy, but higher than that, it's very complicated to solve them. We need trial and error or using numerical techniques. We will examine those 2 methods, the direct solution method and the trial and error method. You can use softwares, you can use the financial calculator in Excel, You can use cash flow analyzer softwares, or you can use online financial calculators to find the internal rate of return for any project. Direct method solution. Direct method solution can be used for a cash flow that has a service life of 2 years, or for a project that has only two transactions, one cash outflow and one cash inflow. In this example, we will examine those two situations. For project 1, I have cash outflow investment at n equals 0 and a cash outflow at n equals 4. And for project 2, I have a project that has service life of 2 years. So for project 1, it's easier to solve for future worth equals 0. If the present worth equals 0, then the future worth is also 0. إذا كانت عند ال present worth بتساوي صفر، معناته كمان إيش عند ال future worth بتساوي صفر. Future worth minus 2000, calculate f given b I star and 4 plus 3500. It's easier now to use the formulas. We cannot use the interest table. We need to use the formulas. The compound interest formula, minus 2000 multiplied by 1 plus I star to the power 4 equals 3500. Solving this equation, we will get I star equals the fourth root of 1.75 minus 1, or I star equals 15.02%. This is the internal rate of return for the first project. For the second project, we will solve the present worth equals 0. Present worth equals 0 minus 2000, and we also are going to use the formula plus 1300 divided by 1 plus I plus 1500 divided by 1 plus I to the power 2 equals 0. Now we will let x equal 1 over 1 plus I star. The equation becomes a quadratic equation. Minus 2000 plus 1300 multiplied by x plus 1500 multiplied by x squared equals 0. We can use the quadratic equation solution formula, and we will find that x equals 0.8 or minus 1.667. And remember that x equals 1 over 1 plus I. x بتساوي 1 على 1 زائد I. إذن at 0.8, x equal 0.8. Solve it for 1 over 1 plus I star. I star is 25%. The other value of x is minus 1.667 equals 1 over 1 plus I star. Solving this equation, you will get I star equals minus 160%. The second solution is rejected. It has no meaning. There's no meaning for a negative rate of return. So the second solution is rejected. Then I star is 25% for the second project. The trial and error method, it has 3 steps. عندي 3 خطوات. Guess an interest rate. Okay. Compute the present worth at this interest rate. And if the calculated present worth greater than 0, increase I. If the present worth is less than 0, then decrease I. And this method works only for simple investments. For non-simple investments with multiple internal rate of returns, you may get a divergence of solution. Sometimes you will get divergence. Let's see this example. Imperial Chemical Company is considering purchasing a chemical analysis machine worth $13,000, and it will result in reduction of labor costs. The machine has an expected life of 6 years, after which it will have no salvage value. The following table summarizes the annual savings in labor cost and the annual maintenance cost for this machine. هاي الآلة حيشتروها بمبلغ مقداره 13,000, and it will require operating and maintenance cost. It will save money as indicated in the table. So the first step is to calculate the net cash flow. Net cash flow is inflow minus outflow. 0 minus 13,000 minus 13,000. 6,000 minus 2,300, 3,700, and so on. Next, we will solve the equation present worth equals 0, but now we need trial and error. So we have to guess or assume an interest rate. Let's assume 25%. Now we need to calculate the present worth at 25%. minus 13,000 plus 3,700 BF at 25 and 1 year, 4,700 BF 25 and 2 years. And for the last 3 years, if you can see that they are a uniform cash flow. I can calculate use the the uniform cash flow formulas to calculate their present worth at n equal 2 and multiply it by BF to calculate their present worth at n equal 0. So I can calculate B given A to find their present worth at n equal 2, then use the factor BF to find their present worth at n equal 0. 6,700 calculate A given B. This is calculate B given A, 25% and 4 years multiplied by BF 25% and 2 years. The answer is 3095. أكبر من صفر, greater than 0. Then if it's greater than 0, increase the interest rate. Now let's assume the interest rate is 35%. Repeat the same calculation. Calculate the present worth, but now at 35%. You will get a negative present worth, minus 339. Since it is minus, this means that I star is greater than 25% and less than 35%. It is somewhere between 25 and 35%. We will use linear interpolation formula to interpolate between 25 and 35. You will get an interest rate of 34.01%. We will repeat this step. Now calculate the present worth at 34.01 and repeat the steps until the present worth approximately 0. This happens at 33.83%. So the internal rate of return for this project is 33.83%. هذا هو العائد على الاستثمار لهالمشروع. يعني بنضل نعيد step 3, we keep repeating step 3, okay, until we get present worth approximately 0. Another example. We have this cash flow, and as you can see, this cash flow is non-simple. The sign changes 2 times. Negative and positive, then negative. So there is 2 sign changes. Since there's 2 sign changes, I may expect multiple rate of returns, 2 rate of returns as a maximum. We solve present worth equal 0. Same procedure, let x equal 1 على 1 زائد I. We will get x equal 0.9091 or 0.8333. Solving for I star, we will get I star 10% and 20%. So we have 2 interest rates, 2 internal rate of returns, more specifically 10 and 20%. And as you can see, this is the first one that makes the project present worth equal to 0, and this is the 20%, and it also makes the present worth also equal to 0. Now the question is, if I'm going to make a decision, in making decisions based on the interest rate or based on the internal rate of return, we compare the internal rate of return to the minimum attractive rate of return. So in this case, since I want to make a decision, بدي أعمل قرار. وفي هاي الحالة, if I'm going to make a decision based on the IRR, بدي أعمل قرار بناء على the internal rate of return, I must compare it to the minimum attractive rate of return. And if the company's MARR is 15%, to which interest rate I must compare it? To the 10% or to the 20%? مع مين راح أقارن؟ مع 10% ولا 20%? If I compare to the 10%, MARR is greater than 10%, so the project is accepted. And if I choose the 20%, MARR is less than 20%, then the project is rejected. So this is the tricky part of the internal rate of return analysis, and especially for projects with multiple rate of returns. The simple question is, I don't choose any of them. ما بقارن لا مع ال 10% أو ال 20%. I do not compare it to the 10% or the 20%. So إذا مع إيش بدي أقارن؟ we compare it to the true rate of return. في هاي الحالة لما يكون عندي projects إلها أكثر من rate of return, this means that at certain points when projects have multiple rate of returns, this means that the project at certain points in its life is generating money and repaying back the loan. Remember that the relation between the company and the project is like the bank and the customer. علاقة الشركة بالمشروع زي علاقة البنك والزبون اللي بياخذ من عنده قرض. The project had took the money from the company, the investment, and he must pay back at the internal rate of return. لازم يرجع الفلوس للشركة بناء على ال internal rate of return للمشروع. And this is what happens for for projects with multiple rate of returns. At certain points of time, the project is generating money and he's giving back the money to the company at the internal rate of return. At other times, the project is not generating enough cash. المشروع مش قاعد بيجيب فلوس كفاية. So the project needs money, بحاجة الفلوس. Then he borrows the money from the company at the MARR, at the minimum attractive rate of return. فالشركة راح تعطي الفلوس للمشروع على ايش؟ minimum attractive rate of return. And this what causes the multiple rate of returns. At certain points of in the project life, it's generating money, it's giving back the money to the company at IRR, at the internal rate of return. برجع الفلوس للشركة الانفستمنت بلس الانترنال ريت اوف ريتيرن. تمام. في لحظات اخرى مش قاعد يجيب فلوس كفايه، بس لحتى يضل شغال الشركه بتعطيه فلوس على الام اي ار ار. Now this is what we are going to examine in the next few slides. Internal rate of return criterion, how to make decisions. For interest rate net present worth, if we consider the net present worth analysis, if you remember that if the present worth is greater than 0, the project is accepted. But this is not always the case with the internal rate of return criteria. And know that the net present worth also depends on the interest rate. So for a single interest rate or single internal rate of return, the situation is easy. For interest rate that below I star, the project is rejected. For interest rates that greater than or less than I star, the project is accepted. Excuse me. For projects with internal rate of returns less than I star, the present worth is positive and the project is accepted. For projects with interest rate or internal rate of returns greater than I stars, the present worth is negative and the project is rejected. So if the internal rate of return for a certain project is less than 44.23%, it's accepted because it makes the present worth negative. If the internal rate of return for the project is greater than 44.23%, this makes the present worth negative, then the project is rejected. This is the simple case. But what about projects with multiple rate of returns? Let's examine this situation. Project B, if you remember from the first example. Project B have 10%, 30% and 50% rate of returns. For the first region, A, the present worth is positive. So any interest rate less than 10% is accepted. For any rate of return between 10% and 30%, the present worth is negative, the project is rejected. And the third region C, between 30 and 50%, the present worth is positive, the project is accepted. And the fourth region D is when the rate of return is greater than 50%, the present worth is negative and the project is rejected. يعني لما يكون عندي multiple rate of return زي المثال اللي موجود أمامنا، الآن إذا كان الانترنال ريت اوف ريتيرن أقل من 10% بنلاحظ إنه البريزنت وورث موجب، فمعناته المشروع مقبول. Then any rate of return less than 10%, the project is acceptable. المنطقة B between 10% and 30%, the present worth ايش مالها is negative. So any rate of return بين ال 10% و 30% حيخلي المشروع rejected لأن ال present worth is negative. المنطقة الثالثة C between 30 and 50%, any interest or any rate of return بين ال 30% وال 50% حيخلي ال present worth موجب، معناته البروجكت accepted. المنطقة الرابعة اللي هي internal rate of return أكبر من 50% حيخلي ال present worth negative، معناته المشروع is rejected. Now this is just in words. How to do this in using calculations؟ كيف بدنا نحسب هذا الكلام؟ We need to classify our investments to pure investment and a mixed investment, or simply we call it the net investment test. What is the net investment test? It is a way to decide if the firm borrows the money from the project during the investment period. How to test? We just calculate the project balance, okay, and the project balance should be less than or equal to 0 for the entire project life. يعني we calculate the project balance year wise, and if the project balance is negative or 0 for the entire project life, it passes the net investment test. What does this mean? The firm doesn't overdraw the money from the project to make its project balance or to make the project in debt، بحيث انها تخلي المشروع يكون مديون للشركة. So if the project passes the test, we classify it as a pure investment. If it doesn't pass the test, we classify it as a mixed investment. So a pure investment, the definition of pure investment is the investment in which the firm never borrows money from the project. تمام؟ يعني doesn't overdraw the money from the project. How to determine if the project passes the net investment test? It is classified as a pure investment. Or every simple investment is also a pure investment. كل simple investment هو pure investment. وإذا متذكرين, if you remember, simple investment that starts negative and changes its sign one time. المشروع اللي الكاش فلو لما بيبدأ بإشارة سالب بغير إشارته مرة واحدة بيكون simple investment. وكل simple investment هو pure investment، بس مش العكس. تمام؟ The mixed investment is the investment in which the firm borrows the money from the project during its period. لما الشركة تقترض الفلوس من المشروع خلال فترة حياته. And how to determine it? If the project fails the net investment test, then it is classified as a mixed. And the relationship, every mixed investment is a non-simple investment. إذا كان المشروع عندي non-simple, if a mixed investment, it always a non-simple investment. And if you remember, a non-simple investment هو المشروع اللي بغير إشارته أكثر من مرة خلال حياته. وكل mixed investment is non-simple، بس مش العكس. مش بالضرورة non-simple يكون mixed. Sometimes a non-simple may be a pure investment. But if it is a mixed, then it must be a non-simple investment. إذا كان المشروع عندي mixed investment, it should be a non-simple investment. Okay, we have 4 projects, A, B, C, and D, and we want to determine if a project is a pure investment or a mixed investment. Now, for project A. For project A, we need to calculate the project balance. The formula for calculating the project balance is project balance at any year equals the project balance at the previous year plus ايش an. At n equals 0, the project balance, and I have forgot to mention one thing, that we need to calculate the project balance at ايش at the internal rate of return, at I star. Okay, so for project A, the project balance at the first year is minus 1000. In the second year, it is the project balance of the previous year multiplied by the interest multiplied by 1 plus I. Okay, minus 1000 multiplied by 1 plus I plus minus 1000. The answer is minus 2336. Second year, the project balance of the previous year multiplied by 1 plus I plus 2000. It is minus $1,122. The project balance in the third year is the project balance of the previous year multiplied by 1 plus I plus ايش 1500. It should equal 0. Remember that the project balance at the terminal year at I star at the internal rate of return is equal 0. This is the third definition, اللي هو ايش تعريف الانترنال ريت اوف ريتيرن اللي بيخليه البروجكت بالانس في السنه الاخيره بيساوي 0. وانا قاعد بحسب قاعد بحسب البروجكت بالانس على الانترنال ريت اوف ريتيرن, so the internal rate of return at the terminal year should equal 0. If it doesn't equal 0, you have done some calculation error in the previous steps. So negative, the project balance is negative in the n equals 0, in the first year negative, in the second year is negative, and at the end it is 0. So this is a pure project. And if you examine this project, it is also a simple project. Starts negative and changes the sign one time. Okay? For the second project, B. Project balance at the first year minus 1000 at n equals 0. At the first year minus 1000 multiplied by 1 plus I, 21.95%. This is the internal rate of return for this project, plus 1600. The answer is positive 380.5. The project balance at the second year, 380.5 multiplied by 1 plus I, minus 300. The answer is positive 164. The third year should equal 0 because it's the terminal year. So it starts negative, but it changes its sign to positive. So this is a mixed investment. And if you examine it, it starts negative, changes the sign one time, two times. It is also a non-symbol investment. For project C, project balance at n equals 0 minus 1000, at n equal 1 minus 1000 multiplied by 1 plus the interest rate, the internal rate of return, 0.2995 plus 500 minus 799.5. The second year, the project balance from the previous year multiplied by 1 plus I star minus 500 minus $1,538. And at the third year, it should equal 0. If you see, it starts negative, 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 and the end it's 0, so it is a pure investment. But if you examine the cash flow, it is starts negative, one sign change, two sign changes, three sign changes. It is non-symbol. And remember that every symbol investment is a pure investment, and every mixed investment is non-symbol. مش العكس, not vice versa. تمام؟ كل mixed investment هو non-symbol, لكن مش بالضرورة every non-symbol investment is a mixed investment. Sometimes it is non-symbol, but it can be a pure investment. And finally, for project D, for project D, we have multiple rate of returns, 10, 30, and 50%. In this case, someone may ask which rate of return to use, 10, 30, or 50%. It doesn't make a difference. ما بتفرق. سواء اخترت ال 10% ولا 30% ولا 50%. If it is simple, if it is a pure investment, it will stay a pure investment. If it is a mixed investment, it will stay a mixed investment. ما بتفرق عندي سواء حسبت على 10% ولا 30 ولا ال 50%. We will choose the 50%. At n equals 0, it's minus 1000. At n equal 1, minus 1000 multiplied by 1 plus 0.5 plus 3900, 2400. The second year, project balance of the previous year multiplied by 1 plus I plus minus $50.30 equals minus $143. And at the third year, it should equal 0. So negative, positive, negative, and 0, it is a mixed investment because it starts the project balance changes its sign from negative to positive, then to negative. So it is a mixed investment. And if you can see this, what does it mean for a project balance? The relation between the project balance and pure or mixed investments. For pure investments, you can see that the project balance is always zero, is always negative. But for mixed investments, the project balance is negative, but here it becomes positive. This means that the company overdraw money from the project, which made the project in debt. الشركة سحبت فلوس بزيادة من المشروع، خلت المشروع ماله في حالة واقع في الدين. تمام. Now we come to decision rule. How to make a decision based on the internal rate of return. For pure investments, the criteria is simple. If the internal rate of return greater than the minimum attractive rate of return, accept the project. If it is less than MARR, reject the project. If it is the same as MARR, doesn't make any difference. For mutually exclusive alternatives, we will use the incremental analysis. We will come to that later. For mixed investments, it is somehow complicated. We cannot compare the internal rate of return with MARR because we have multiple rate of returns. If I want to compare with MARR, which one I will choose, 10%, the 30, or the 50%. So in this case, we need to calculate what we call it the return on invested capital, RIC, or sometimes we call it the true rate of return. Okay? And we make the decision based on the RIC. If the RIC greater than MARR, accept the project. If it is less, reject the project. If RIC equals to MARR, there is no difference. Example 7.7, we have Merco Incorporation, is a machinery builder in Louisville, Kentucky, is considering investing $2,500,000 in a complete structural beam fabrication system. The net cash flow is as shown below. What is the project internal rate of return? And if Marco's MARR is known to be 18%, is this investment justifiable or not? And as you can see, this is the net cash flow diagram. I have initial investment is 2.5 million, annual income uniform of 772,500, and I have a salvage value at the end of $188,000. So there is only one sign change. So this is a simple investment, and because it is simple investment, it is also a pure investment. Calculating the present worth for this project, calculating the internal rate of return of this project, present worth equals 0. Solving this equation, we will have that the internal rate of return is 34.46%. Now, since MARR is greater than 18%, then the project is acceptable. Now, for mixed investments, how to calculate the RIC? In this case, we have two interest rates. The internal rate of return, the project is dealing with two interest rates, the MARR and the internal rate of return. So step one, we need to define the MARR. minimum attractive rate of return. It must be known. Step 2, now we will calculate the project balance for each year. Okay, and the project balance may, in, at certain times of the project life, may be calculated at the internal rate of return, or we will call it now I interest rate, or based on the minimum attractive rate of return. And remember that the project balance at the first year is always equal to A1. Okay? Now for the years after the year 1, we will apply this formula. For year 1, it will be the project balance from the previous year multiplied by 1 plus I, or multiplied by 1 plus MARR plus A1. It's either 1 plus I or 1 plus MARR. Which one to choose, I or MARR, depends on the sign of the project balance of the previous year. If the sign of the project balance in the previous year is negative, we use I. If the sign of the project balance of the previous year is positive, we calculate it based on the minimum attractive rate of return, and continue with this up to nth year. The project balance at any year, this is the general formula, the project balance at any year equals the project balance of the previous year multiplied by 1 plus I or 1 plus MARR plus AN. And to choose 1 plus I or 1 plus MARR depends on the sign of the previous project balance. If it is negative, we choose I. If it is positive, we choose MARR. And remember that the project balance of the terminal year equals 0. Okay? And now the last step is determine the value of I by solving the terminal project balance equation at the last year. This is in capital. And the interest rate calculated from this step is the return on invested capital, or sometimes simply we call it the true rate of return. And then in the next lecture, inshallah, we will see how to calculate the RIC.